correlation coefficient R. We have numbers between -1 and 1. If you have it exactly in the middle, 0, that is no correlation. The further away from 0 on the left side would be a negative correlation. It gets stronger and stronger as it approaches -1. As it approaches the right side, it has a positive correlation. When it approaches 1, it gets stronger and stronger. So by looking at this chart, let's look at some of these questions. On number 1, R, the correlation coefficient is 0.41. Positive or negative? As a positive number. Strong or weak? 0.41 is somewhere right here. That's in the weaker area. So we'll put weak. Let's look at another one. Number 5, R is negative 0.53. That's a negative number, and it is strong because it's closer to -1. It's in this area. Okay, try the rest of these examples on your own, and then we'll go to the next part. If you look at number 8, this is a positive correlation. It's a positive slope. Positive is increasing, negative is decreasing. Since it's really close to being a straight line, that would be considered strong. For this one, this would be considered weak. And it looks like it's more negative than positive. Try number 9. So R is the correlation coefficient, the percent of accuracy the line of best fit is to the data. And the line of best fit is just the line that you make through the majority of the points. Let's do some more examples. Correlations of graphs and tables. Say if each graph or table has a positive, negative, or no correlation. If a graph has a correlation, draw a line of reasonable fit. Let's look at number 2. If we draw a line of reasonable fit here, it looks like it's negative. Number 3, I would say that would be no correlation. If you use technology to calculate the specific R, it might not be exactly 0, but it would be pretty close to it. And let's look at number 10. We could plot these points. This would be positive. Okay, try the rest of these on this page on your own. Linear and exponential correlation coefficients are. So, using technology, you'll find a regression of the data. You could do this on both the TI Inspire or Desmos. For this example, let's go ahead and use Desmos. So go to desmos.com/calculator. So from here, let's go ahead and make a table. So we press the plus sign and go down the table. And then we'll type in all the values that are in our given table. Okay, once you've put in all the data points, we'll click on another row and type in our formulas. To find a linear regression, we type y1 tilde, it's the little squiggly line, mx1 plus b, where m is the slope and b is the y-intercept for our regression, or line best fit. And then for our exponential regression, we do y1 tilde a times b to the x1 power. To get a regression, a correlation coefficient for this regression, we need to have log mode turned on. Notice it does change our numbers a bit. Depending on the data, it could vary it by a lot or a little bit. Log mode changes the way that the calculator will calculate the equation. So looking at this, our correlation coefficient for the linear is 0.4675. That is positive and is considered weak because it's closer to 0 than it is to 1. Now for the exponential regression, we have a correlation coefficient of 0.4901. That is positive, and it's still weak. Since these regressions are both weak, neither of these functions would be ideal models for this data of class number and student weight. Using Desmos, try these other two examples on here. We have number of items and price, and the years in college and money. Notice on number 2, you can't do an exponential regression because the data point 00 would break the regression formula. After finishing these two examples, go ahead and go on to the next video.